This is the third lecture for chapter 15, and we're going to start off with Le Chatelier's principle. So looking at Le Chatelier, what we're looking at here is how we can shift, move equilibrium, and there's three things we're going to be looking at here. We're going to be looking at temperature, pressure, and concentration of reactants or products. And we'll see how these things individually affect equilibrium. So the Haber process we mentioned a little early on, and this is simply just a way to produce ammonium. This is how we produced fertilizer, and it's something that really has changed the human race, and enabling us to get to well over 7 billion people, and still counting. But how does this actually work? Well, we know that in order to make ammonia, which is necessary as a fertilizer, you have to be able to react hydrogen gas with nitrogen gas, and we do this under really high pressures and high temperature. So we're just going to look at it from an equilibrium standpoint with Le Chatelier. So I know I have this equilibrium already established. So I have these gases in this container, and nothing's really happening. I only have so much ammonia to work with. But what I see is if I pump in extra hydrogen, which I'm going to increase the concentration right here. Whoops. So if I increase the concentration right there, I've stressed the system. So based on this equation right here with the reactants, notice that hydrogen does react with nitrogen. So if I stress the system by adding too much hydrogen, it is going to grab some of the nitrogen and push in the opposite direction to relieve this stress that I just added. So notice that the amount of nitrogen goes down because it has to react with the hydrogen to remove the stress. And then the ammonia concentration does go up. But after a period of time, we can see that all three become constant. So notice the values are different than what I initially started with. It doesn't mean they return to the same concentrations. The concentrations are all different. But the equilibrium, the K value, is going to be the same as what it was. So whatever this K value was here, that is going to equal whatever the K value was here. It's a new equilibrium, but the same value. Sounds confusing, but that's what it is. And here's a little diagram of what the actual process is. The main point here is how do you keep this going? It's an amazing setup. It's a beautiful setup. All you have to do is condense the ammonia and remove it, and that is going to continuously shift the reaction to the right. So as long as I'm removing some of this ammonia, I'm stressing the system, and I have to replace that. I guess that's this is a 3, and that's a 2. So as long as some of this stuff is being removed from the system, that means it is continuously pushing to make more of this ammonia, which is a very necessary component of fertilizers. So that's how we're able to produce all the plant food that we need, is this process right here, discovered in the early 1900s. All right, another change that we can have in a system is with temperature. Notice what we have here. This is a very important point here. This is the only disturbance that affects the K value permanently. So remember, you can change it and you get a Q value, but it's always going to shift back to the original K value. But all K values, whether you're talking about rate constants or equilibrium constants, they are temperature dependent. So if I change the temperature, I have permanently changed the K value, and it's going to reestablish someplace else, whether it's higher or lower, based on the reaction's endo or exothermic. Okay, last one on here is catalysts. Misconception with catalysts means they're going to push the products, right? Okay, well that's going to affect the K value, right? No, it just means it happens more quickly. So as you can see in the bullet point there, that it makes the reaction go faster both in the forward direction and in the reverse direction. So it just makes it go faster. Doesn't make it, more favorable for products or reactants. It just makes it go faster. So you establish equilibrium more quickly, but the K value does not change. Okay, and we're just restating all that here. You can look at this on your own, and I think we're done. Last lecture.